This one is the second video on the chapter Arithmetic Progression. In the first video, the introduction of arithmetic progression and some simple questions related to the chapter was covered, but here we'll take some little bit advanced questions on the same chapter. So let's proceed with some different questions. But before we start, let's understand what suggestions are given here to make our solution easier or easiest. Generally, we assume terms of an AP as A plus D, A plus 2D, A plus 3D onwards as different terms of an AP, where A is the first term and D is the common difference. But here some suggestions are there. Let's observe. The first suggestion is, if you have to assume odd number of terms, in fact odd number of consecutive terms of an AP, the arithmetic progression, then we assume as it is mentioned here. For example, suppose you had to assume 3 terms, then instead of assuming A plus D, A plus 2D as 3 terms of an AP, we are suggested to assume A minus D, A and A plus D. But you have to be very much careful that in this assumption, your first term of the AP is A minus D, the second term is A, and the third term is A plus D, and the common difference is D only. And if we had to assume 5 consecutive terms of an AP, then it is suggested to take these 5 terms as A minus 2D, A minus D, A plus D and A plus 2D as the consecutive terms of AP. Let's observe the second suggestion. If we are to assume the number of terms of an AP as even numbers like 2, 4, 6, so on, then the assumption values are different. In fact, then we are suggested to assume values as is mentioned in the block. For example, if we are to assume 2 consecutive terms of an AP, then we should assume as A minus D and A plus D. And again be very careful that A minus D represents the first term and A plus D represents the second term. But the very important point here is the common difference. Here the common difference is 2 times D, that is 2D. If we are to assume 4 consecutive terms of an AP, then the terms assumed should be A minus 3D, A minus D, A plus D and A plus 3D. And here too, the first term is A minus 3D and common difference is 2D. Similarly, if we are to assume 6 consecutive terms of an AP, then the terms should be A minus 5D, A minus 3D, A minus D, A plus D, A plus 3D and A plus 5D. And here the first term is A minus 5D and the common difference is 2D. Altogether, we are not forced to assume the values of an AP this way. It is just a suggestion, and that suggestion makes our solution the easiest. So we should follow this. Let's see what this statement says here as notes. Note that the above suggestion is to make the solution shorter and easier by replacing simultaneous equations in two variables, or even a quadratic equation in one variable, into two simple linear equations, each of which in one variable only. And it's obvious that if we get an equation in one variable only, and that too in linear form, then obviously the calculation becomes very easy. In fact, solution becomes very easy. And here the last but a very important statement, that is, we must not forget that in this kind of suggested assumptions, the first term is never A. Now is the time to take questions in which some consecutive terms we need to assume, and we'll observe here that if those terms are assumed as we write in a simple form as A plus D, A plus 2D, and so on, and the next one is the suggested way as A minus D, A plus D, and so on. And let's see what difference we get in the solution. Here the question is, divide 216 in three parts which are in AP, and the product of first term and third term is 5040. From the question, it is very much clear that three consecutive terms of an AP we need to assume. And here, according to the suggestion, I am assuming these three terms as A minus D, A, and A plus D. Here, let's observe the first block. According to the question, the sum of first three terms is 216. So hence T1 plus T2 plus T3 is equal to 216. And T1 here is replaced with A minus D, T2 is replaced with A, and T3 is replaced with A plus D. And we simplify this equation. And here we very easily understand that the unknown D gets cancelled and the whole equation in two variables gets converted to a single variable. It means an equation on two variables now we get on one variable only, and very easily we find the value of that variable. And here we find that D gets cancelled and A survives, and finally we get the value of A, 72. Let's observe the second block. The second statement of the question says that the product of first term and third term is 5040. Hence, according to the question, T1 multiplied by T3 is equal to 5040. And in the next step, according to the assumption, T1 is replaced with A minus D and T3 is replaced with A plus D in the equation. Now observe the remaining statements of the solution. We find A square minus D square is equal to 5040, and hence D square is equal to 72 square minus 5040, because the value of A we obtain 72, and finally the value of D is 12. Now we get the value of A, that is 72, and the value of D 12. Hence the third block, let's see the value, the terms of an AP we had assumed a minus d, a and a plus d. So after putting the value of a and d here in these assumed values, we get the first term 72 minus 12, the second term 72 and the third term 72 plus 12. And hence these three consecutive values of the AP are 60, 72 and 84. Let's observe what the statements given below here says. It is clear from the above assumption process that each of the two equations in two variables are easily replaced with equations in one variable, and hence solution automatically becomes very easy. In the next few questions, I'll show you the solution in two different ways. First way, where the value we assume in a normal way, and the second way, the value we assume as suggested. Let's take another question. Question number 7. Split 207 into three parts such that these parts are in AP and the product of the two smaller parts is 4623. Let's solve this question in two different ways. First way, to assume three terms as usual, a plus d and a plus 2d. Let's observe the first block. According to the question, the sum of these three terms is 207. Hence T1 plus T2 plus T3 equal to 207. Observe the second term, where we find that T1 is replaced with A, T2 is replaced with A plus D and T3 is replaced with A plus 2D, and the equation is simplified, and after the simplification we get a linear equation in terms of two variables, and the equation is A plus D equal to 69. Let's observe the second block. According to the next statement of the question, we find that the product of two smaller parts is 4623. Hence T1 multiplied by T2 equal to 4623. Observe the next line. We find that T1 is replaced with A and T2 is replaced with A plus D. Fortunately here, A plus D is replaced with 69, which is the equation number 1, where the value of A plus D we get 69, and automatically the equation gets simplified to the lowest form. Finally, the next term of the equation is A multiplied by 69 is equal to 4623, and we get the value of A 67. Now observe the third block. Here the value of A67 we get, and we put the value of A67 in equation 1 and we get the value of D, and that is 69 minus 67 is equal to 2. Finally, with the value of A67 and the value of D2, we get three terms of the series, that is 67, 69 and 71, and here the solution completes. Let's take the same question and try to solve in a different way. Here the three values we assume as we are suggested, that if odd number of values are there to assume, then assume as shown here. Since three values we have to assume, so they are A minus D, A and A plus D. Let's observe the first block. According to the question, the sum of three terms of an AP is 207. Hence T1 plus T2 plus T3 is equal to 207. Observe the next line, where we find that T1 is replaced with A minus D, T2 replaced with A and T3 replaced with A plus D, and we simplify the equation, And the advantage here is d gets cancelled and the equation directly gets converted into one variable, that is a, and the value of a comes 69. Let's observe the second block. According to the question, the product of first two terms is 4623. Hence, T1 multiplied by T2 equal to 4623. Observe the next line where we find that T1 is replaced with A minus D and T2 is replaced with A, and the product is equal to 4623. And in the next line we replace a with 69 and simplify the equation, and we get the value of d, that comes 69 minus 67, and that is 2. Let's observe the third block. The value of a we get 69 and the value of d we get 2. And the third block we had to put the value of a and d back and get the terms of the AP. And finally we get these three terms 67, 69 and 71. Now you compare this solution and the previous solution and find out what advantage is there in the second kind of solution and work accordingly. Here we have another question which looks same as the previous two questions we discussed just now, but it is different from them. Let's go through the question. The sum of three numbers in AP is 15 and the sum of the squares of the extreme terms is 58. Find the numbers. In fact, find those three terms of the AP. Let's assume these three terms what usually is assumed as a plus d and a plus 2d. Let's start the first block. According to the first statement of the question, the sum of three terms is 15. Hence, T1 plus T2 plus T3 is equal to 15. Observe the next statement where we find that T1, T2 and T3 are replaced with A plus D and A plus 2D respectively. And then the equation we simplify and we find that a linear equation is obtained in terms of two unknowns A and D, and the equation is A plus D equal to 5. Let's come to the second block. According to the next statement of the question, the sum of the squares of the extreme terms is 58. Hence, the square of T1 plus the square of T3 is equal to 58. Observe the second statement and where we find that T1 and T3 are replaced with A and A plus 2D respectively. And we go on simplify the equation, and here we find that the equation obtained looks very tough and very skillfully we have to solve so that without any much burden we get the answer. Now simplification goes on. The control from the end of the second block goes to the top of the third block where it is a lengthy expression, but I target to get the expression containing a plus d because the value of a plus d we know that is equal to 5, and hence the equation we get a plus d whole square plus d square is equal to 58 by 2, that is 29. And in the next line we replace a plus d with 5 what we obtained in the first equation, and very skillfully the equation in two variables is converted to a equation in one variable, and then we get the value of d 2. So till here the value of d only we are getting, and that is 2. Now observe the last block. We put the value of d, that is 2, in equation number 1 and we get the value of a, and a comes 3. Now taking the value of a as 3, that is first term, and the value of d common difference, that is 2, we generate this series. It means we find these three terms. So the first term is 3, the second term is 5, and the third term is 7. Let's take the same question again and try to solve the way we are suggested to assume the terms of an AP. Here, according to the question, three terms are there. So we are suggested to assume these three terms as a minus d, a and a plus d. And let's proceed the solution with these three values, and we get the equation a minus d plus a plus a plus d equal to 15. And here we clearly find that d gets cancelled, and immediately an equation in two variables gets converted to one variable, and then d gets cancelled and we get the value of a 5. Now observe the second block. According to the second statement of the question, the sum of the squares of the stream terms is 58. Hence, a minus d whole square plus a plus d whole square is equal to 58. We simplify the equation by replacing a with 5 as obtained earlier, and then after further simplification we get the value of d, and that is 2. Now with the value of a as 5, that is first term, and the value of d, that is 2, and it is common difference, we obtain these three terms as 3, 5 and 7. Now here three questions are given to you. Question number 9, 10 and 11. These three questions you solve, and if you get any problem, I'll discuss this, or whatever questions earlier are given, all those questions will be discussed in the class. So you don't need to worry. But try to solve yourself without any help. Here we complete the second part of the chapter Arithmetic Progression. In the third part, we'll see some different kind of questions with completely different ideas. Thank you.